All right, in our the first question we're asked to do is come up with some sort of graph that illustrates the following properties. So in an odd graph, not odd as in weird, but in an odd graph, we're looking for some sort of symmetry either in the first and the third, or in the second and the fourth. So some sort of graph where whatever I draw in the first, so something like this, also shows up again in the third. That, so that's a pretty standard example of what an odd function looks like. For an even function, it's either going to be symmetrical in the first and second, or in the third and fourth. Um, so, nice textbook. So that image needs to repeat itself in the second quadrant. And then the neither example, well, it can be pretty much anything you want it to be. Something that doesn't exhibit any of that symmetry at all. All right, next up, number 4, evaluate the following function. So, let's see, 3 times something squared minus 5 times something minus 4. And what am I going to fill in the blank? I'm going to fill it in with a 5. I just need to simplify that. So that would be 3 times 25, so 75 minus 25 minus 4. Let's see, 75 minus 25 is 50 minus 4, which is 46. Okay, number 5, start off with the same process. Oops. So 3 times something squared minus 5 times something minus 4. And I'm going to fill in the blanks with the a plus 2's. Alright, and then I just need to multiply and just be careful about that. Alright, so 3 times, well, a plus 2 squared, that's a squared plus 4a plus 4, minus 5a minus 10 minus 4. And then, of course, we can distribute the 3 in. So 3a squared plus 12a plus 12 minus 5a minus 10 minus 4. And then it's just a matter of combining all of our like terms together. So we got 3a squared, 12a minus 5a, so that's 7a. Let's see, we got 12, take away 10 is 2. 2 take away 4 gives me negative 2. So we end up with 3a squared plus 7a minus 2. Okay, number 6, find the difference quotient of the following. So need to set up, say, x squared plus x plus, minus 3. Okay, so we'll start off with x plus h. So that's something squared. Sorry, something squared plus something minus 3, and then minus something squared plus something minus 3 all over h. Okay. In the first two blanks, I'm going to base it off of this f of x plus h. So x plus h goes in there. And in the last two blanks, it's just an x. So it really didn't change the last half of it. Alright, so x plus h squared would be x squared plus 2hx plus h squared plus x plus h minus 3. And I got a little sloppy here because that whole thing is being subtracted. So it should be minus x squared minus x plus 3 all over h. All right, the x squareds are gone, so I'm left with 2hx plus h squared. The x's are gone, plus h, and then the 3's are gone. Okay, that's nice. And then I want to divide every term by h, so that leaves me with 2x plus h plus 1. Okay, so in number 7, 8, and 9, I want to look at my domain statement. That tells me which one of my two pieces I need to stare at. So g of negative 5, that is an x value that's less than 0. So I'm going to that's the y value is defined by x minus 2. So x minus 2. So put the negative 5 in there, and I get negative 7. Okay, g of 0 is defined by the absolute value of x plus 2. So the absolute value of something plus 2, evaluate to 0, and that would be the absolute value of 2 then, which is just 2. And then g of 5 comes from the, again, the absolute value of x plus 2. And so I'll put a 5 in there. So that's the absolute value of 7, which is 7. So there should only be one numerical answer for any of those types of questions. All right, in graphing a piecewise function, I want to first start off with what are called transitional values. This particular graph changes from top to middle to bottom at 0. So I want to figure out what's going on at 0. So in that top equation, 0 comma, so if I come over here, 0 plus 4 means there's an ordered pair at 0, 4. Now the symbol tells me that it's an open circle, so I'll just write myself a little note there. At 0 itself, it happens to equal 5. And then this last one, so at 0, so 0 minus 1, I get negative 1. And again, the symbol says open. This equals sign says closed there. Okay, so I've now got 3 points that are the transition of where this function switches places. So now I'm going to set up a little table. And the reason why I have 3 pieces, I've got 3 equations, 3 different pieces defined. So the middle being the 5, that's x minus 1, and up top there we have x plus 4. Okay. Now, since 0 is where all the fun stuff is, and I already went to the trouble to find those ordered pairs, I know that, and then I'll just pick numbers like before 0 and numbers after 0 just to get a good idea what's going on in the picture. And then I'll just evaluate in the different equations. So negative 1 plus 4 gives me 3. Negative 2 plus 4 gives me 2. So I can see that they're going down from there. Here I get 1 minus 1, so I get 0. And 2 minus 1, so I get 1. Alright, so then I'm going to plot my points. I'm going to start with my open and closed ones. So I make sure I put open circles on those. So that's an open one. That's a closed one, and there's an open one down there. Okay, then I'm just going to plot points. So negative 1, 3, and negative 2, 2, and those are all connected to that open circle there. And I can see that they're all going to head down in that general direction. Then we have, let's see, 1, 0, and then 2, 1. So I can see those two things are going off that way. So that's a picture of my piecewise graph. Alright, next up is just reading some information off of a graph. We'll start with any intervals where it is decreasing. Okay, so in this picture, when I come in on the x-axis, so I'm kind of starting off here at negative infinity, and I'm moving along, and when I get to -5, I see the y values are the same. That means they're constant. They don't start decreasing until I get to -1, and at -1 they decrease up till I get to 0, and then once they hit 0 they start going up again. So this is only the interval in which case this function has got decreasing y values is only from -1 to 0. Constant, by the I do have an example of that. So it starts off at negative infinity up till -1, which is that flat piece right there. Domain, there are no holes or gaps as far as x coordinates go. The only spot that I was nervous about was right here at -1, because I can see the open circle, but I can also see the closed circle down below it. So there does exist an ordered pair that has -1 comma something. Looks like it's -1 comma -2. So the domain for this graph is all real numbers, negative infinity to infinity. Range, okay. So range, you got to think I'm starting here at the bottom of the y-axis, and I'm going to go up. First time I actually encounter a number is at -3, and as I keep going up, I keep seeing the graph. I mean, the arrow keeps going up on me, so -3 up to positive infinity. Just sort of a side question, why did I bracket it? How come I didn't parenthesis it like I did everything else? And so in this case, the answer is there's an actual ordered pair right there at 0, -3 that actually contains or includes a y value of -3. When we talk about increasing, decreasing, and constant, we always use those as open circles. So always kind of say that we're up until this point we are decreasing, or up until this number. So we're not saying at that number. I mean, how do you decrease at a number? It's up until the number you're going to be decreasing. Anyways, minor point. And then the last part of number 11, f of -1. So when x is -1, what is y? And that's actually the ordered pair that we looked at earlier, so that's just -2. All right, -12, increasing. So I'm looking at where do I see, again, I'm on the x-axis, so I'm over here at negative infinity. And I'm moving along the x-axis, and when I'm at, what is that, 1, 2, -3. So from -3 up till 0, I can see that the y values are getting bigger. And at 0, I can see the y values are decreasing. And they stop decreasing right there, in which case they start increasing. So from 0 out to 1, 2, 3. So 0 to 3, they're decreasing. Oh, sorry, increasing. Oh, I said it, but then I didn't write it what I meant. Starting at 3 out to wherever this graph stops at, the y values are increasing. Now, as far as decreasing goes, out here at negative infinity, I can see the y values are going down. And they are going to keep going down up till I hit here. So here they're going down, there they're going up. So from negative infinity out till -3, they decrease. And they start decreasing again when they get to 0 out to 3. Max or min. Okay, so this is sort of a hand-me-down question. On the actual test, there's a different graph there, obviously. I'm not testing you on this graph, so that'll make more sense when you see that graph. In this case, I have a max at, so we'll say a max at 0, what is that, 1, 2, 3, wow, 0, 3, a lot of 0, 3s. And we have a min at 1, 2, yeah, of course. 3, 1, 2, 3, 3 comma negative 3. All right, find f of negative 2. So f of negative 2 is right there. So that would be negative 2, 1. And find f of 0, so that would be 0 comma 3. So that would be 3.